So we'll focus now the most famous vineyards of the Burgundy, la Côte de Nuit and la Côte de Beaune in the Côte d'Or department. What is la Côte? What we usually call la Côte when you're in Burgundy is la Côte de Nuit to the north and la Côte de Beaune to the south. It's a hill slope vineyard. It's a narrow strip. It's orientated from the northeast to the southwest. It's about 60 kilometers long. It's 37 miles, and it starts to the north in Dijon, and it goes up to Les Maranges in the south. Most of the vineyard is located in the Côtes d'Or department, but you also have a little part in the Saône-et-Loire with Les Maranges, sorry. And this narrow strip is located at the edge between some plateaus to the west and a wide valley, the Saône Valley, eastward. The hierarchy of the vineyard is quite extraordinary. You've got Grand Cru, the highest level, and you've got 33 lieux-dits climat that are with the Grand Cru level. You've got some Premier Cru, and here to the right, sorry, you've got the map of Gevrey-Chambertin. You see the Grand Cru in dark red, the Premier Cru that are frank red. You've got some communal, the village appellation. Here, for instance, it's Gevrey-Chambertin. And you also have some regional appellation, Bourgogne, Bourgogne-Aligoté, Corto-Bourguignon, and so on. And they are beige and grayish grayish on the map. So different levels supposed to give different qualities of wine. And to try to justify, to explain the different levels of the Burgundian hierarchy, to try to explain the unique specificities of the wines, the qualities, and so on. A lot of things have already been told, and that's why I found the right book. And you see myths and legends of the Burgundy vineyard. So, are there really some well-known explanations? Is it a fairy tale for wine lovers? I'll tell you roughly about this, but probably the storytelling is not necessarily the truth. So we'll see together for sure. First of all, when you arrive in Burgundy, people is most of the time convinced that the hierarchy is deduced from the soil and subsoil characteristics, and you probably heard or you can hear about the, in French, modèle bourguignon de construction des terroirs. So do the Burgundian wine growers use the soil properties, the subsoil nature to define their hierarchy? If it is the case, I'll be able to tell you a geological history, able to explain why you've got such subsoil under the Grand Cru in brown, unique subsoil under the Premier Cru in green, another kind of soil and subsoil under the communal, the village appellation with the gray rock, and at least the less good regarding the quality in light blue for the regional appellations. So is there really a Burgundian model based upon rocks and soils? We'll see it. Other people are very proud of the climat, the lieu-dit in Burgundy, And they're going to explain to you that you've got a mosaic, an extraordinary diversity of the terroir. If it is the case, each lieu-dit of Gevrey-Chambertin is unique regarding soils and subsoils characteristics. So as a geologist, I should be able to explain to you why each lieu-dit is unique. Let's see if I'm able to or not. To try to explain this extraordinary diversity of the terroir, people very often explain to you, but in Burgundy, you know, we've got clay, argile, and limestone, calcaire. So argilo-calcaire, argile and calcaire, clay and limestone. This is the key for understanding. More or less clay, more or less limestone. Are there really, because there are 1,247 lieux-dits climat along the Côtes, are there really 1,247 shades of gray between clay and limestone? Does the clay be important in the soil, in the subsoil, in both? What is important? And the same for the limestone. Is it important to find some limestone in the soils, in the fine-grained particles, as rocks, in the subsoil? A lot of questions. Some people also are going to explain to you that you've got along la côte, along in Côte de Nuit and Côte de Beaune, the word of the good with the premier cru and the grand cru, and the word of the bad with the regional appellation downward. And there is a reason why there is a good lieu-dit along the slope and bad places at the bottom. There is a big fault. So maybe it's dangerous, it's hazardous, sorry, and we'll see if really this big fault is something true or not. The faults are supposed to be under the roads. If it is the case, it's a picture that has been taken in 2011 in Fukushima. If really you've got faults on the roads, take care when driving between Dijon and Beaune. It could be hazardous if tectonic is active again. Once again, we'll see if really the roads have been built above the faults. Among the legends that are circulating regarding the subsoils of the Côte de Nuit and the Côte de Beaune, there is one famous one that has been built above a scheme drawn by Mr. Ra 50 years ago. He noticed, and that's true, that the oldest rocks are outcropping close to Gevrey, just north of Gevrey-Chambertin, and the youngest one under the vineyard are outcropping close to Volnay. And he tried to explain that probably there could be some gentle bands, gentle undulations that could explain the oldest rock in Gevrey-Chambertin and the youngest ones in Volnay. And he said, between quotes, that there could be an syncline in Volnay and an anticline, a fold with a concave shape, in Gevrey-Chambertin. He was very intelligent, this guy, and he put some quotes between he put the names between quotes. And you have to keep in mind also that the Côte, the vineyard, is not a straight line, it's a broken one, but the scheme Pierre Rat has done, it's like it was just a straight line. You forgot to turn and to change the direction. So we'll see also for this one if it's true or not. Another one that I like regarding myth in Burgundy. there are some reds, mostly in the Côtes de Beaune, and some whites, mostly in the Côtes de Nuit. And for sure, the soils are dedicated to white wines south of Beaune, and they are dedicated to red wines north of in the Côtes de Nuit. And there is a French sentence: sur un sol rouge, on plante du rouge, and sur un sol blanc, on plante du blanc. So reddish soils, the reddish soils are well suited for the white grapes, and the light color soils are better suited to the white varieties. Everything that the French are going to establish, it's a French rule with so many exceptions. And you see Volnay-Clos des Chênes with a light color soil and a light color subsoil is nice red wine. Pommard Premier Cru les Eupneaux, maybe the subsoil is too light to produce some red wine. Meursault Charme and Meursault Perrière, the soil seems reddish to plant some Chardonnay. So one more mystery that we try to solve. And to finish with my list, my long list of legends, the monks are supposed to have been able to delimitate properly the plots, tasting the earth. So one question is, does the earth reflect the taste of the place? And does the taste of the place be something that you can approach clearly without tasting the wines? If you taste the place, you taste the soil, the subsoil, but don't forget the landscape, the slope, the exposure, the elevation, the climate, because microclimate is very important to cultivate the vine. And I looked for in the archives a lot, if I was able to find a monk tasting the earth. Unfortunately, I just find one trying to drink some wine in a cellar. So, is it a simple explanation to this puzzling hierarchy? Is it possible to understand the limits of the clima and the hierarchy only with soil and subsoil knowledge? So we'll see. Let's go. As I am a geologist, we are talking about geology. And the geological history is responsible for a lot of things regarding the vineyard in Burgundy. It's responsible for the present-day landscape. It's responsible of the rock type and the rock distribution, and it is responsible for the soil diversity, at least partly. The geological history is very long. If you just keep in mind 3 main steps, you'll be able to understand properly the landscape of the Côtes de Nuit and the Côtes de Beaune, the soil and the subsoil distribution, and the soil and the subsoil nature. And those 3 pictures, those 3 events are the following ones: a turquoise blue sea with a tropical climate during the Jurassic, a valley like the Afar Rift during the Oligocene, and a landscape somewhere in Alaska or Siberia during the Quaternary. So let's go and try to understand more. So we'll move up to the Jurassic, between 200 and 135 million years. And at that time, Burgundy looked like that. This is an important step. This is the first one. This is the period, the Jurassic, during which the sediments deposited. So you have to imagine Gevrey-Chambertin or Puligny-Montrachet or whatever you want between Dijon and Les Maranges, looking like that during the Jurassic, between 172 up to 145 million years. the landscape was flat. There was no hill slope and no côte. Everything was flat. The area Burgundy was covered by a shallow sea, and the open sea was where the Alps are now. And the climate was tropical, so a shallow, warm tropical sea. Turquoise blue, for sure. During that time, during the Jurassic, between 172 up to 145 million years, specific kinds of sediments deposited, the carbonates. If you've got pure carbonates, you will get some limestone, sands or muds at the beginning when they deposited. And if you've got a mixture between carbonates and clay, you've got a specific rock that we name a marl. So if you've got between 1/3 and 2/3 of limestone and clay, you will get a rock that is called a marl. You've got different kinds of limestone, and most of the time along the côte, most common is limestone made up of calcium and carbonate. From place to place, and especially around Pomar, we find a lot of calcium and magnesium carbonate that we name the dolomite. There is no deposit made up only of clay, so there is no shale along the côte. The soft sediments that deposited during the Jurassic are made up of a mixture of clay and limestone, and those are marls. So you've got few pictures here of different kinds of marls, different kinds of limestones that you can encounter along the côte. And here are some different limestone, because during the whole Jurassic, it's a long period, the depositional environment did not remain always the same. From time to time, we had some reefs, and you see here some corals that are easy to distinguish due to the erosion there and also here. So you've got some corals here, and in between you've got some storm deposits with sands made up of shell debris, of fossils, and a specific type of fossil named crinoid. And you've got here pieces of crinoids, tiny stars, less than 1 centimeter in width. And when it was living, the animal, because it is an animal, looked like a plant. And this is a present-day picture of crinoid somewhere in an ocean. So if you've got some storms, if you've got some rains, you can have what we call crinoidal limestone. If the depositional environment is less favorable to the limestone precipitation, if it's protected from the wave action, you can have a kind of bay, a protected bay, where some oyster can live quietly. And this is why you've got a deposit about 15 meters thick. So that is a marl, mixture of clay and limestone, with numerous small oyster shell, less than 1 centimeter for the length. And this small oyster is named Ostrea acuminata. And you've got here a marl with Ostrea acuminata. And you've got also there another picture with Ostrea acuminata marl below the forest and the soil. If you're located just at the bottom of the shore face, you can have fine-grained limestone with beds indicating surface deposits, and also with secondary nodules made up of silica, some chards, what we call chai in French. And this is the Premo limestone. Premo is the name of a small village just south of Nuit Saint-Georges. So you've got Premo limestone there. If you've got wave action, always removing the sand, you'll get some small sphere of limestone with concentric precipitation of limestone, looking like fish eggs, and that's why the name of the rock is white oolite. It looks like fish eggs, millimetric sphere. And you see here a former quarry with big stratifications, with the beddings indicating wave deposits. And you could also have encountered deposits that occurred in a very, very quiet environment, protected from the wave action, from the tide action. And this was a lagoon 161 million years ago. And typically, the Comblanchien limestone, very well-renowned, used as a marble worldwide, even for the opera in Sydney, for instance. The Comblanchien limestone is the result of tiny microcrystal of limestone that precipitated in a lagoon and that cemented to form massive metric beds with quite no fissure, hard to explore by the roots of the vine or the other plants. So another one, and the last one, I think, for my list is what we call Dijon-Corton limestone or Grenu limestone. You see here a former quarry in Les Perrières in Beaune, and you clearly see my hammer is the scale for the picture. You clearly see beddings, sorry, here, indicating that this kind of limestone was a sand and it deposited under storm events. So whatever the environment, a lagoon under the action of the tides, wave action, a bay protected from the wave with less carbonate precipitating. During the Jurassic, limestones, layers of limestones and marl are going to stack one onto the other with quite no lateral changes, no facies variations. And everything occurred in a turquoise blue sea, shallow one. The sedimentation went up like this up to the end of the Jurassic, and also during the next period that we name Cretaceous. And this period started around 145 million years up to 65 million years. The sea was slightly deeper, like in around 200, 300 meters, and typical deposits are chalk. At the end of the Cretaceous, at the beginning of the Paleocene, of the Tertiary era, there has been a big change because the African plate started to collide the European one, and at that time, the deep ocean related to the shallow sea in Burgundy started to disappear, to close, and the Alps started to rise at the same place. The weight of the sediments that are accumulated since the beginning of the Jurassic made all the layers to become compact, to become cemented, and instead of muds and sands, we are now in front of limestone layers, marl, and so on. Because the Alps are rising, the sea retires from Burgundy around 65 million years ago. So there is no marine deposits since 65 million years here along the Côtes. And because of the Alps, the area has been uplifted above the sea level, and the former deposits, the first one was the youngest one, so the Cretaceous one, started to be eroded. So if you remember the last cross-section with a lot of green layers, around 35 million years, quite old Cretaceous deposits have been eroded, but there is no reason to imagine a steep hill slope, and there is no reason also to envisage faults at that time. Only erosional processes tended to make the Cretaceous layers to disappear. At that time, around 34 million years, at the beginning of the period of time that we name the Oligocene, the second event that is responsible for the present-day landscape, rock nature, and distribution occurs. And at that time, you can imagine that Burgundy and La Côte de Beaune and Côte de Nuit could have looked like that. That is a place somewhere in Africa, in the Great Lakes area, in Ethiopia, in the Afar Rift, something like that. During the Oligocene, the Alps continue to rise. And because the Alps continue to rise, you've got just before the Alps stretching from the North Sea there up to the Rhine Valley between Alsace and Schwarzwald, Black Forest, I don't know English translation, the Saône Valley, the Limagne in the Massif Central, and the Rhône Valley up to the Languedoc there. And this stretching is a consequence of the Alp rising. During 11 million years, you've got a huge tectonic activity, earthquakes, and you've got the Saône Valley that's going to appear. Geologically speaking, the Saône Valley is named Bressgraben. So at that time, the hillside, the hill slope appears. The sediments, the Jurassic layers deposited between 172 up to 150 million years, something like that. But the hill slope has been created between 34 and 23 million years. So you've got a huge tectonic activity. You've got a lot of faults. You've got a rift. So blocks and compartments are collapsed downward towards the center of the basin. And the future vineyard of La Côte is going to develop onto several compartments westward. Between 34 and 23 million years, the faults are active. Each time there is an earthquake, you've got a movement, and the collapsed block continues to be further down. Nowadays, if you look at the faults, you can see big froze, big shifts between the layers that were former unbroken and horizontal, and you've got from 1 meter up to 30, 50, 100 meters of throw, but this did not occur in one time, but it's just successive earthquakes that led the throw to increase. Because you've got a long time, since 23 million years, with no earthquake, the erosional processes tended to smoothen the landscape, and very often you are unable to see the faults. Apart here you're in Le Montrachet, in the Côtes de Beaune, and the oblique plane that you see here, it's a fault, and this is this fault. And it's possible to see it because there were marls there, easier to erode. The marls have been eroded, and the Chassagne limestone to the west is more resistant, very resistant to the erosion. And that's why you can see the fault plane. But most of the time, you're unable to see the fault planes nowadays along the coast. This is an example there. In Gevrey-Chambertin, you've got some marl, you've got a fault, you've got some limestone. But if you look at the landscape, you don't see a difference in elevation between marl and limestone. Apart few places in Les Musigny, in Le Montrachet, where you can't see it. So definitely, we had some seismic evidences. We had a lot of evidences now. There is no big fault. You've got numerous faults. You've got a gently dipping hill slope and no cliff. You don't have to envisage a big hole with 1,050 meters of void. It's just a lot of faults, but as far as the Breisgraben initiates, it has been filled by the sediments that have been eroded upslope and accumulated downslope. So here you've got a seismic profile, even if it's not well interpreted, you clearly see that there is no one big fault, but just a soft and a gentle landscape filled by the sediments as far as the relief as the valley created. And definitely a lot of faults, sorry, and no folds, no anticline, no syncline. You've got some faults parallel to the valley, and you've got also some faults transverse, oblique regarding the main direction, and you don't have some faults. Some folds, no anticline, no syncline. During the Oligocene, when the hill slope has been created, the upslope part has been submitted to erosion, and you've got specific kind of limestone that accumulated downslope, made up of species of Jurassic limestone transported, rounded or sub-rounded, and cemented by a continental shaly limestone, pink colored, and the pink salmon, sorry, and the pink salmon conglomerate is well renowned as an Oligocene deposits. If you are far away from the areas where you had some inputs from upslope, you've got also lacustrine sedimentation, but a fine-grained one, still pink salmon, but it's a marl, a mixture of clay and limestone. So marl and conglomerate with the pink salmon colors are typical of the Oligocene deposits that accumulated downslope when the hill slope created between 34 and 23 million years ago. Since the end of the Oligocene, there is no major tectonic activity in Burgundy. During the Miocene and during the Pliocene, no tectonic activity. At the end of the Miocene, or somewhere around the end of the Miocene, the tropical climate disappeared, and it's an alternance between temperate climates and very cold climate, ice ages, that took place during the Quaternary. And this very cold climate, this ice age, those ice ages are responsible for very important surface deposits. So at that time, you have to imagine that the Burgundy and the Côtes de Beaune, Côtes de Nuit, should have looked like somewhere in Alaska or Siberia. So during period of temperate climate, and especially during the Pliocene, thick marl deposits, often gray gray-blue, sometimes yellowish when oxidized, deposited, and they are named marne de Bresse, the Bresse marl, and they are very, very common and very often dedicated to something else than the vine cultivation. But there are few vines onto that, and even communal one in Vaune-Romanée and Gevrey-Chambertin, for instance, cultivated onto those marl with a village level. The breast marl deposited under temperate climates, and it's a carbonate. They are rich in carbonates, and they deposited into ponds, marshes, probably with a lot of mosquitoes and something not very interesting for living close to. The ice ages are very important because the cold climate has been responsible for a lot of important surface deposits. So for sure, it's not the Côtes here. You've got a valley with symmetric edges, but you have to imagine something quite similar along the Côtes since 2 million years ago. The surface deposits can be debris and scree made up of gravels, and these gravels result from the daily freeze and thaw cycles that fissured the limestone each night, each evening when the sun sets. When the sun sets, the water becomes ice, and the pressure fissures the limestone. And when the sun rises in the morning after, the temperatures become above zero, and the ice melts and the water deepens into the fissure. The fissure increases the night after when the ice fissures the limestone, and so on and so on. And those gravel debris, those gravel scree are very famous and quite common along the Côte de Beaune and the Côte de Nuit. They are known as créslité, bedded scree, bedded gravels, and they are very helpful for the vine cultivation. For instance, in Le Chapitre or Le Clos du Roi in Marsanais, or les Montluisans in Moret-Saint-Denis, or La Montée Rouge, les Bressans, part of Les Grèves in Beaune, Lulune in Pomard, and so on and so on. So very common and good substrata for the vine cultivation. The surface deposit can be some scree or some debris, but they can also be some alluvium. During spring and summer, the melted water is above the plateau and at the bottom of the slope, and above the plateau, it can deepen into the frozen soils. So it tends to reach by gravity the Saône Valley, and at that time, some valleys have been dug by seasonal rivers, and the valleys are locally named combes. You've got here a picture of a combe in Marsanais-la-Côte, and you see the valley. At the outlet of the valleys, you've got a lot of alluvial deposits, amalgamated lobes, sorry, and they form a kind of fan that we call alluvial fan. And those fans are made up of materials of very varied size, from the tiny size of the clay or silt up to the pebbles or the blocks, and sometimes big blocks. So the combes are not the result of glaciers tongues. The combes are clearly the results of seasonal rivers that dug the valleys during the spring and summer when there were some very cold climates here in Burgundy. And here you've got the picture of La Comblaveau to the left in Gevrey-Chambertin, with the Comblanchien limestone outcropping at the edge of the valley, and alluvial deposits at the outlet of the Combe. So, because you've got during the Quaternary some alluvial deposits at the outlet of the valley, some colluvium and some debris, some scree along the slopes, you've got some surface deposits that are also very important substrata for the vine cultivation. So just to finish the presentation, if we can summarize everything. The present-day landscape is a result of a very long history. First of all, during the Jurassic, the sedimentary rocks, the limestone, the marl, deposited in a flat area, a shallow tropical sea. During the Oligocene, between 34 and 23 million years ago, the hill slope created with a lot of faults. There is no one big fault, but a lot of faults. So you've got the geometry, the rock distribution, and also the hill slopes, the landscape that initiated since 34 million years ago. And at least the third event, since the last 2 million years during the Quaternary, due not to tectonic activity, but to climatic factors, and the cold and very cold climate, no glaciers, but a permafrost, a deeply frozen soil all year long, flowing only superficially during spring and summer, that led the deposits of scree, debris, alluvium, colluvium along and at the bottom of the slope. Since 10,000 years, soil develops, plants grew onto the hill slope, and the vine is cultivated since something like 2,000 years now. So if we now consider both the map of the Appalachian and the geological map, you see that you've got a clear hierarchy. But regarding the geology, the rock distribution is not matching properly with the limits of the lieu-dit. However, even if you don't have a clear link between geology and the limits of the lieu-dit, you've got some links regarding the wine properties. And even if it's not easy to try to establish some links between soils and subsoils and taste, aromas, or flavors, you've got some influences and some complex influences of the geology. But definitely, there is no direct relationships between the nature of the subsoil and the level of the hierarchy. Thank you very much for your attention.